Hello students. Now we are continuing of the study on vectors. In the previous classes we have discussed about how to add and subtract vectors. While using the addition or the subtraction, so we have used both graphical method and also how to find out the resultant magnitude and resultant direction of the addition of two vectors here. Well, the resultant magnitude was given as R is equal to square root of A square plus B square plus 2AB cos theta. This gives the resultant of two vectors A and B making an angle theta with respect to each other. This only gives the resultant magnitude. But since vector is a two-dimensional, that means it both has magnitude and direction, we also need to find out the direction. Students, if you imagine that alpha is the angle made by this resultant with reference vector. One of these two will be taken as a reference vector. That means the direction of either A or B is taken as reference direction. If we take A as the reference direction, then B will be making an angle theta with respect to A. And similarly, resultant R will be making an angle alpha with respect to A. Then what will be the formula to find out the value of alpha? That is given by alpha is equal to tan inverse. In the bracket, we are going to consider and tell you the knack of remembering this formula. We know that tan theta, usually in general, if you consider some angle tan, say phi, it will be represented as sin phi divided by cos phi. We all know this formula. Here also we are going to use the same thing. Tan alpha is equal to tan inverse some angle. So that will be what should be written in the brackets. We are going to write, take this angle theta. So first we are going to write sin theta. In the denominator we are going to write cos theta. Just like this formula. But here, between A and B, we are going to use the vector which is not the reference vector. That means, if we take A as the reference vector, then we have to choose B and it should be multiplied to both sin theta and cos theta. It will be represented as B sin theta divided by B cos theta. They will not cancel each other. In the denominator, we have to add the vector which is taken as a reference. That is A. Therefore, this is the formula to find out the direction of the resultant vector. This represents the magnitude, and this will represent the resultant direction. But here, you should remember that this is the angle made by resultant R with respect to A. That's the meaning. For your knowledge, if we choose the value of or direction of B as a reference one, then what will be the angle? I will draw you the diagram. There are two vectors, say vector A and vector B. Imagine that the resultant will be somewhere in this direction. The angle between A and B is represented as theta. So this angle is represented as theta. Then resultant will be in this particular direction. Then this angle is represented as what? Like this. If we assume B is in the reference direction, Then we can say that A is making an angle theta with respect to the B, and R is making an angle, say here, this angle, not alpha. It will be different angle. Let us assume it as gamma. Okay, let us take it as gamma, or I will take it as phi. Another Greek letter phi. You should learn the Greek alphabets. They are not. They will be often used in different to represent different physical quantities. So that's why we need to learn about the Greek letters. This is Greek letter. Fine. Obviously, here when we consider B as a reference direction, then what will be the formula to find out the resultant magnitude for this R? Again the same. It is the same. R will be is equal to square root of, you can write A square first or B square. Formula will remain the same. A square plus B square plus 2AB cos theta. Resultant magnitude will have the same formula, but the difference is with the direction. Because now the angle is not equal to alpha. Alpha is the angle made by resultant with respect to A. We need to find out the angle made by the same resultant R, but with respect to B. That means we need to find out the value of phi. What is the formula? Same thing. All we need to know is the method in physics. You cannot by heart everything. You should learn how to learn physics. Not like other subjects, we cannot by heart the physics. So therefore, if you understand the concepts well, then obviously everything will be easy. You have to apply your mind. You have to start thinking about physics. Not just like you will by heart everything. You will write the notes and you will by heart everything. Not like that. Never try to by heart physics. That's my first and even final suggestion. Never try to by heart physics. Then what should be the value of phi? Then again same thing. Tan inverse. Everything else will be the same, but we have to make necessary changes. Here, in this place, which is not connected with any of the trigonometric function, sin theta or cos theta, so that is the reference vector. So therefore here, since D is the reference vector, it will be D plus. Okay. Other one is connected with, which is not a reference one. In this case, B. But on the others, it will be A. It will be connected with both sin theta and cos theta. So therefore, it will be A sin theta divided by B plus A cos theta. So this angle is alpha is with respect to A, vector A. That means with respect to the direction of vector A. On the other hand, so this angle will be with respect to the direction of vector B. And also we can find out the relation between these two. Relation between these two. What is the value of phi? It is nothing but, phi is nothing but theta minus alpha. That's the relation. We can clearly see that from the diagram itself. The total angle is theta, which is the angle between A and B. Phi is the angle between B and R. Alpha is the angle between R and D. So therefore, this is the relation among them. So this is only for you to understand the concept. Our effort is to understand the concept. Once you understand the concept, the physics will become very easy, not like other subjects. Once you remember this, then you will never forget this. This is the way you should study the physics. You should learn to analyze the equations. That's my concern. I'm always trying to do that. So let us move on further. We are going to learn little more about the vector algebra. That means we are going to learn about mathematics which are involved in the vectors. After these two, we are moving on to the addition and subtraction. We are moving on to the multiplication. And students, remember that multiplication and division are same as addition to subtraction. So, if you learn the multiplication properly, then obviously it will be everything about the vectors. Now, I will rub this and we are moving on further. But before jumping into the multiplication of the vectors, we need to discuss about the sum of the parts about the vectors. Since a vector has both magnitude and direction, we can write any vector as a product of its magnitude and its direction. How do we do that? That's the question. Imagine that we have a vector A and the representation of the vector A is as shown in the diagram. If you observe the textbook, then it will be represented by bold letters. How is that? It will be made very dark. Vector A is written like this. But if you try to do that in the exam, what happens? The people might or evaluator might think that you are overwriting it. So therefore, while writing on the paper or the board, you are using the arrow to represent the vectors or bold letters. It is good in case of the computer sum. What is the magnitude of vector A? That is represented by the letter A. So this is the magnitude of the vector. How do we represent its direction? It is, again we are going to write A, but on top of it we are going to place a cap like this. If it is not visible clearly, I will write it in a large letters. So this is representing the magnitude of the vector A, and its direction is represented by again a letter A, but we are going to place the cap which is also known as caret. Here we are going to call it as a cap, A cap. What is the meaning of this A cap? It is known as a unit vector. We know that if you multiply anything with 1, for example, I will take an example of two numbers. If you multiply 7 with 1, what will be the answer? The same thing. 7 is 7. If you multiply 100 with 1, answer will be 100. If you multiply in generalize, if you multiply x with 1, what will be the answer? X is 7. Therefore, we already know that if we multiply any quantity with 1, then it will not change the answer. So therefore, we are multiplying the magnitude of a given vector with a unit vector. What is the meaning of unit vector? It is the vector which has magnitude equal to 1. A vector which has magnitude equal to 1, so that is known as a unit vector. It could be represented in any way, so it depends on us. Okay? But when we consider the magnitude of this, then it will be equal to 1. But this cap represents the direction of this unit vector, which is same as that of the vector A. I hope you have clearly seen this. So therefore, I will run this. So therefore, magnitude of A into a unit vector representing its direction. Why we are using A? Because it is a unit vector which represents the direction of the vector A itself. If we need to write the vector B in the same form, how do we do that? It will be equal to the product of the magnitude of vector B, which is represented as B, into the unit vector representing the direction of B. Hence, it will be represented as B cap. If we use another one, vector, say x, vector x, then it will be equal to x into its magnitude into unit vector, which shows the direction of the x. So I hope it is clear now. That is how we are going to represent them. Okay. Now we are moving further. What if we are going to multiply a vector with a real number? Any number here, not an imaginary number. You will study that in mathematics in detail. But when we multiply any vector with a number, then what happens? For an example, I will give a numerical values. If we have a vector which is given as, which is having the magnitude of 5 and its direction, I will represent it as a sum. Say I cap, where I cap is representing the direction of the vector which has the magnitude 5. And what is the magnitude of I cap? It is equal to 1. It is a liter. If I multiply this vector, let it be represented as vector A. Then what is the value of A here? What is the value of A in this case? It will be equal to 5. That's the magnitude of A. What is the value of A cap here? That will be equal to I cap. So that is how we are represented. Okay. What is the magnitude of A cap? How do we represent that? It is represented between the modulus. Okay. If you need to represent the magnitude of any vector, A, then it will be represented as modulus of vector A. Okay. Or in simple words, it will be represented as A, modulus of vector A. But if we take the modulus of unit vector, then what will be the answer? It will be equal to 1. That's the meaning of the equation. Now we have observed this. Since we have observed this, if you multiply this vector A is multiplied with some number. Say I will take it as 6 into vector A. Just an example. Then it will be equal to another vector because the magnitude is here, not the direction. If you multiply a vector with a number, then the magnitude of the resultant vector changes. So it will be represented as vector B. It is now a different vector. I hope you are understanding this. Now, when we need to write the magnitude of vector B, what is the magnitude of vector B? I will write it as magnitude of vector B enclosed within the two straight lines, modulus of B, or it will be also represented as B. What is its value? It will be is equal to 6 into vector A, which is equal to 5 into I cap. Okay, so for 6 into 5 into I cap, so that will be equal to how much? 6 into 5, 30 into I cap. So for magnitude of vector B will be equal to now equal to 30. It is 6 times the magnitude of vector. But what is the direction of vector B, which is represented as B cap? It is again the same as before. So therefore, what is the conclusion here? It is equal to A cap, or that will be represented as I cap. It remains the same. What conclusion we can draw here? When we multiply a vector with a number, the magnitude of the resultant vector changes by the real number. How many times? What is the value of the real number into the magnitude of the original vector? So that is the magnitude of the resultant vector. But the direction of the resultant vector remains same as the original vector. It never changes. Only there will be change in the magnitude. Simple. If this vector is represented by a line of this length, then If you multiply it with 6, then we will get a line which is 6 times larger than the vector. But direction will remain same. It is parallel to the vector A itself, but it will be 6 times smaller. That's the meaning. Now we can generalize it. Generalize this. How? Instead of writing with any number, we can put something like lambda. That's where algebra comes into play. That's why you were studying. So you have studied the algebra in textbook. In physics, we are going to generalize the things. Lambda could be anything. It could be anything. It can be 1, 0, 100, 1000, minus 5. It could be anything. Okay. So therefore, the resultant vector will be lambda times the magnitude of vector. Resultant vector has a magnitude equal to lambda times the magnitude of vector. But direction of the resultant vector B remains same as the direction of the original vector. So this is how we can multiply a vector with a real number. Again, the addition is not over. Now we have seen that. So again, moving back to the triangle of factorization. Triangle of factorization. Here, we know that if there is a vector A represented in this direction, again one more vector represented by B in this direction, and if you use the parallelogram law of factor addition, then obviously resultant will be some idea. I have not constructed the complete parallelogram. We do not need it. But this is represented as R, and mathematically it will be represented as R is equal to A vector A plus vector B. That means a single vector R can be split in two ways. One is vector A, another one is vector B. This method of splitting a vector in two vectors or three vectors or components. For example, I will run this. I will take a single vector represented as R. This is a single vector R. Okay. I will try to find some colored chalk pieces. Okay. I got three colored chalk pieces. So here, this is a vector R. Okay. If I am going to use the triangle of vector addition, I will draw two more vectors. I will do this. One is represented like this. One is represented like this. I hope you are able to see the different color. I took the blue color. So this is represented as vector A. And the point where the A ends, I will start the B and it will be the head of the R. So from the triangle of vector addition, we know that resultant R, this vector R, can be represented as vector A plus vector B. Okay, this is one way of representing it. We divide R, a single vector, into two vectors, sum of two vectors. This method of splitting a vector into different forms, that is known as a resolution of a vector. Resolution of vectors. Dividing a vector into more than one part. Okay, one vector is divided into many parts. So that is known as resolution. And this method is known as resolving a vector. We have resolved a vector into only two components. We can do it in many times, but for time being, two vectors. But now question is this the only way of dividing a given vector, splitting a given vector into two parts, and these parts are known as the components. R is a vector, A and B are components of the R. Is this the only way? No, we can use different vectors here. I will in. I will choose another line, another vector, someone in this direction. I hope you are able to see the color of this purple piece. I will take this as a vector P. Okay. It will be starting from the tail of the vector R and it will terminate somewhere here. And this from the head of the vector P, another vector Q starts. And it will terminate at the head of the R. This is known as a Q. Again, if you use the triangle law of vector, P and Q are in the order of a triangle. R is in the opposite direction, so therefore obviously this same vector R can also be represented as sum of vector P plus vector Q. Same thing, different way you have resolved it. Okay, these are the only two forms. No, I will take one more thing. So here, one more line. Now I am using the yellow chalk piece. I will take it as an X, vector X. Again, similarly, another one, vector y. Again, if we add vector x and y, again we will get the r. Therefore, vector r can also be represented as vector x plus vector y. So therefore, remember that there are infinite ways in which we can split a given vector into its components. We can keep doing that. It will not over. So therefore, this method is known as the resolving vector. But we are not going to do like this. There is one single method of resolving the vector. What is the limitation that we are going to put? Is that the two components should be perpendicular to each other. In the given example, A and B are not perpendicular to each other. P and Q are not perpendicular to each other. X and Y are not perpendicular to each other. These are the components of the same vector R, but they are not perpendicular to each other. What we are going to choose is the two vectors which are perpendicular to each other. I will now use the white chalks. I am going to use the white chalk itself. Now I am going to take the two vectors. So one here. Starting from the R itself, I will draw a line like this. Okay, a line like this, exactly up to this point. I will represent, since it is along the x-axis, and this direction, this is a reference direction, we assume that it is along the x direction, and this component of the vector R, I will represent it as an R subscript x, that is, it is component of the R along the x-axis. Okay, this is the vector. Then from the head of the Rx, I am going to draw another vector which is perpendicular to the Rx. Then it should reach the tip of the R. Therefore, here, so I have drawn a little bit longer. I have made necessary changes. Therefore, a straight line which is perpendicular to this. This angle is 90. This one is along the y-axis, so therefore it will be represented as vector ry. Now, vector r is represented as the sum of rx and ry. Now you can look at this way. When you do that in this way, where here these two components rx and ry, they are perpendicular to each other. What is the meaning of perpendicular? They are making an angle of 90 degrees with respect to each other. 90 degrees with respect to each other. Okay. Now, this method of resolving a vector into two components which are making an angle of 90 degrees with respect to each other. So that is known as rectangular components. Rectangular components. These are rectangular components. components. Usually we do this. We do not use any method, any other method. They should be making an angle of 90 degree with respect to each other, components. Okay. I hope you have understood this. Now I will run this. And only we are going to concentrate on the rectangular components. This is a vector. Let us represent it as a vector A. Now we need to resolve this. That means split this vector into two rectangular components. How do we do that? First, we are going to consider the component of this vector along the x-axis. I am going to draw a coordinate axis, x and y axis, taking the tail of the vector A as the origin. Okay, I am going to take this as O as the origin, and I am going to draw an x-axis. It is not a vector; it is just an axis. It will extend it up to infinity on either side. Okay. Similarly, I will take a y-axis, which is perpendicular one. And we know that x-axis and y-axis are perpendicular to each other. Then, from the tip of the vector A, I am going to draw two perpendiculars. One to the x-axis, other to the y-axis. Okay. When we draw a perpendicular from the tip of the vector A to the x-axis, then from the origin to this point of intersection, up to this. This is one of the component of the vector A, which is along the x-axis. Therefore, I will represent it as a subscript x. Vector A subscript x. Similarly, when I draw a perpendicular from tip of the vector A to the y-axis, it will cut somewhere here. Therefore, up to this, up to the arrow mark, that is representing another component of the vector A but along the y-axis. Therefore, it will be represented as A subscript 1. What happens? This is how we are going to resolve any vector into two rectangular components. Only we need to know the rectangular components. All these other components are not necessary. We need only rectangular components. I hope you have understood this. So therefore, it is clear that we can resolve any vector into its rectangular components. How do we represent this vector A? In this case, it will be represented as vector A is equal to its component along the x-axis plus its component along the y-axis. Okay. Then, if we have another vector B, how it can be represented in terms of its rectangular components? Same way, it will be equal to. I am not going to draw the diagram. So, let's draw the diagram. I will take this again blue color copies to represent the vector P. So, this is vector P. Then, its components. So, this will be representing Bx, vector Bx. Again, by drawing a perpendicular to the y-axis from the tip of the B. So, we will get By, vector By. So, what is the value of vector B? I will use the same color, blue color is there. It will be equal to vector Bx plus vector By. And so on. Whatever may be the vector. Similarly, they can be represented in terms of their rectangular components. Any vector. Okay. What is the use of these? The use is it will make easier for us to add these vectors. How? We will see. And also in the previous concept, we have understood that any vector A, it can be represented as the product of its magnitude and unit vector representing its direction. Okay. Similarly, even the components can also be represented in the same manner. Even the component Ax will be represented as the magnitude, product of magnitude of Ax into unit vector which is representing the direction of x direction. Now we have a definite direction, x direction. Ax is along the x direction. So how do we represent that? The unit vector which represents the x-axis is represented as I cap. I cap is a unit vector which shows the x-axis. Direction shows the direction of x-axis. Similarly, y-axis, the direction of the y-axis will be represented by another unit vector. So it is represented as I j cap. When we use the 3-dimension, that means z-axis also. If z-axis is like this, it is perpendicular to the plane of the board and it is directed towards it. Then it will be known as z-axis. But if you are going to draw that on the board, then it will be represented like this. This is the z-axis. Okay, if this has also component along the z-axis, then it will be represented as Az, vector Az. And what is the unit vector representing its direction? It will be k cap. Okay, I cap, j cap, k cap. They are representing x-axis, y-axis, and z-axis. This much is clear. Maybe for simplicity, let us forget about the z-axis. Only we are going to keep it simple. So therefore we are going to use only two axes, x and y-axis. For now. For now only. Then we have to introduce that. If you understand this, then we can introduce it. So how do we write this here? Now vector A can be represented as the magnitude of Ax, which is represented as Ax, into the unit vector representing the direction of vector Ax, which is I cap, plus magnitude of Ay into unit vector representing the direction of Ay, j cap. Okay, similarly, for B, it is dx into again I cap itself, because whether it is Ax or the dx, they are along the x-axis, they are along the direction of I cap itself. So therefore it is I cap itself. Similarly, for by into j cap. Okay, for the 2-dimension. If it is in the 3-dimension, vector is in the 3-dimension, if it is origin is located on the plane of the blackboard only, but it will be directed somewhat like this. It is coming out of the plane of the blackboard. Then z component will also represent. Then what will happen? It will be Az, vector Az. Also here it will be vector Bz. So therefore this components will be equal to Az into k cap plus Bz into k cap. So this is how we can represent it. This is one more way of representing the vector. Now we are going to add these vectors. What is the value of resultant? Say resultant R. It is given as vector A plus vector B. What will be its value? How do we write this? So that will be represented as vector A. We are going to substitute this. Vector A is equal to Ax into I cap plus Ay into j cap plus Az into k cap. Similarly, Bx into I cap plus By into j cap plus Bz into k cap. This is the value of vector B. When we add these two, again here also the rules which you have followed in the algebra, so that is valid here also. We can add only those terms which have eigen. We can add this. We cannot add this. Actually, the magnitudes will be represented by some number. Here we have used a general term here. A could be anything. It could be 1, 2, 5, 10, -10, -1, minus anything. Similarly, AX, AY, AZ, BX, BY, BZ. They are the numbers. Okay. But these I cap, J cap, K cap are directions. Only that vectors along the same direction they can be added. These two can be added. AX and AY cannot be added directly. Therefore, it will be resultant vector will be again it can also be represented in the same way. It will be represented as vector Rx into I cap plus vector Ry into J cap plus Rz into K cap. It can be similarly represented, but what are the values of Rx, Ry and Rz? That's the question. Value of Rx is equal to how much? It will be is equal to Ax plus Bx. Value of Ry, it is equal to Ay plus By. Rz will be equal to Az plus Bz. So this is how we can write this. That's the resultant vector. That is how we are going to find out the addition of two vectors. This method is known as analytical method. Usually, the vectors are represented in two different ways. One we are already seen in the previous class. Like using the resultant magnitude and resultant direction. Then you have to make use of these formulas. If two vectors are given like this, if vector A is given as, say, assume that it will be equal to 10 Newton, and vector B is represented as 5 Newton, they are maintain an angle of 60 degrees with respect to each other. Then, how do we find out the resultant? We use the formula. Resultant magnitude is equal to square root of A square plus B square plus 2AB cos theta. We know the values of A, B and theta. Here only magnitudes of A and B are directly given. Their direction is not given. Their direction with respect to each other has been given. So the resultant direction, I will take it as a phi itself. Resultant direction that will be equal to tan inverse B sin theta divided by. Do not get confused. We can keep on changing the terms. It is not always necessarily alpha. We have the freedom to choose the terms. Okay? You might think earlier I had written it as alpha now phi is with respect to B. We have the choice. It is the formula. We can form the formula. But we should know what is the meaning of the terms involved in that formula. That's important. So phi will be equal to B sin theta tan inverse B sin theta divided by A plus B cos theta. So this is the formula. This formula we have to use. But what if these vectors A and B are given in this form? Shall I write the example here? I will rub this. Imagine that. Let it be here, sir. Imagine that two vectors, vector A is given as example 5 into I cap plus 3 into J cap minus K cap. This is the one. I will explain it later. Similarly, vector B is represented as 3 into I cap minus 5 into J cap plus 4 into K cap. Now we need to find out the resultant R. Find out the resultant R, which is equal to vector A plus vector B. How do we do this? That's the question. Now we can add only the terms which are along the x direction. Only those terms along the y direction can be added. Similarly, along the z direction can be added. We cannot add a component along the x-axis with a component along the y-axis. It will not allow this. Our knowledge of algebra do not allow this. We know the formula. If something is given like this, for an example, if it is given as 5x plus 3x, what will be the value? We take x as a common and we will add these two. So therefore it will be represented as 8x. This is the answer. If it is given as add 5x with 3y, would you write it is equal to 8xy? No, it is not possible. We will just write it as 5x plus 3y itself. We cannot add the numbers. If we need to add them, then these terms should be same, x should be same. Then only if it is x, other one is y, we cannot add the numbers. Same rule applies here also. If we can only those numbers which have I cap or j cap or k cap. Simple. But here we have introduced the negative sign. What is the meaning of the negative sign? Negative sign indicates that the given vector, the component of the vector is along the negative axis. That means here it is minus k cap means the magnitude of the component of A along the z axis is 1. 1 into A cap, which is equal to A cap. But it will be in the direction opposite to the I cap. I cap opposite. That means it is along the negative z axis. Similarly here, this is 5 times but in the negative y axis downwards. That's the meaning. In vectors, negative sign indicates in opposite direction. One direction, negative means opposite direction. That's the meaning. And also after resolving the vectors, these are the only 3 possible directions, not any other direction. The actual vector can be in any direction, but we have divided them into 3 rectangular components. Now what is the value of R? Add these two, which will be equal to 8 I can. Add these two, add this, subtract off according to your rules. Plus 3 minus 5 will be equal to minus 2 j cap. Similarly, when we add these two, then it will be equal to plus 3 k cap. So what is the meaning here? So this is Rx. Sorry, this is Ax, Ay, and here one is Az. Bx, By, Bz. What is the value of Ax? It is plus 1. Ay plus 3. Az minus 1. Similarly, Bx equal to plus 3. By equal to minus 5. Bz 4. What are the resultant? Rx, Ry, Rz. Rx is equal to how much? Same thing. Ax plus Ax. 5 plus 3. Ry equal to Ay plus By. 3 plus minus 5, which is equal to minus 2. Similarly, other one. Rz is equal to Az plus Bz. So therefore it is minus 1 plus 4, which is equal to plus 3. So that is how we do it using the analytical method. So this is the way of representing it. Okay. Then one more thing. What is the magnitude of this? Magnitude of this. Magnitude of R. If you need to write like this, a single value, how do you do that? If you want to write a single value for A, if you want to represent this in this form, if you need to find out the value A itself, how do you do that? How do you do that? That is again a simple formula which will be explained in the next class. But I will give the formula now itself. How do we do that? It is based on this formula itself. Resulted by the same formula, but I will explain it in the next class. I will give the formula. If we need to find out the magnitude of vector A, which is represented in this form, analytical form, then how do we represent its magnitude? Like this. It will be equal to square root of the magnitude of vector A, which is given as 5 I cap plus 3 j cap minus 1 k cap. Actually, it will be not written as minus 1 k cap, it will be just written as minus k cap. In order to convey the message, I have written this as 1 k cap. It will not written like that. So then what we need to do, we have to take the square of each component along the x-axis. X square plus ay square plus az square. This represents the magnitude of vector A. Shall we do that? We can substitute the values here. Yes, we are going to do that. Ax is equal to 5. So for 5 square, I will write it for the first time. 5 square plus ay equal to 3. So for ay square, which will be equal to 3 square. Then this plus addition symbol of the equation. Az square. What is the value of az? It is equal to minus 1. So it will be equal to minus 1 square. Okay. What is the value here? 5 square. 25. 3 square. 9. Plus minus into minus 1. Minus 1 into minus 1. It will be again positive. Therefore, it is 1 itself. So the answer will be how much? Square root of 35. You can find it using the calculator, but it will be answer is represented as minus square root of minus 35. Okay, almost closer to the 6. That is how we are going to find out the value. Since we are squaring it, even the negative terms will become positive. Similarly, can we find out the magnitude of vector B? In the same way. What is the magnitude? Square of 3, which is 9. Square of minus 5, which is equal to again plus 25 itself. Square of 4, which is plus 16. When we add all these, we will get how much? 50. Then we have to take the square root of this. So the magnitude of vector B, only magnitude, will be equal to 50. Therefore, if this has a magnitude equal to 50, this one has a magnitude equal to A equal to square root of 35. This one, B, has a magnitude of square root of 50. Similarly, for this resultant, what is the magnitude of the resultant? Square of 8, square of minus 2 plus 4. Again, so this is 3 j cap. Sorry, 3 j cap. So which is 3 square equal to 9. How much it is? It will be equal to square root of 64 plus 4 plus 9. How much? Of course it is 77. Square root of 77. Okay. Vector A plus vector B. Vector A has a magnitude of 35. Vector B has a magnitude of Vector A has a magnitude of square root of 35. B has a magnitude of square root of 50. But when we add these two, resultant will be equal to square root of, it has a magnitude of square root of 77. Direction matters. Okay. We cannot add these two and answer will be obtained as a unified. It is not necessary always correct. Okay. Because the direction also matters, since depending on the angle between these two, the magnitude is lesser than the sum of these two, which is equal to square root of 77. That's the meaning. In vectors, we cannot add magnitudes directly. We have to consider the direction also. I hope you have understood both the methods. Mathematical methods, if only magnitudes and angle between the two vectors are given, how to find out the resultant? Both magnitude and direction of the resultant. Using this method. And if they are given in the rectangular components, if vectors are given in rectangular components, how to find out the result? Both are same. Okay, this is representing both magnitude and direction. Usually, vectors are given in this form. In very rare cases, it will be given in this form. When only magnitude or the resultants are important, then we are going to do this. And these vectors which you have discussing in this year for the first year, it is also helpful for you in the second year also. Whenever vectors are involved, we have to use this algebra. Vector algebra has to be used. And one more thing, I have not mentioned the value tan inverse. So we will discuss that, how to find out the value of tan inverse something in the next series of classes. When we are discussing the mathematical tables, I will explain everything. How to look out for what are the uses of logarithmic tables and also trigonometric tables. What are the uses and how to use them? We are going to discuss in the next classes or in different series of lectures. Thank you for joining.